Hi everyone, welcome to Google Developer Space channel and thanks for joining us today. We are super excited to be hosting CodingGirls for their second time on our platform. Yeah, do make use of the live chat and let us know where you are tuning in from. Before we begin, let me briefly introduce who we are and what we do. Google Developer Space is a platform for developers and startups from around the region to learn, connect, engage, and be inspired. As part of the developer relations team, we aim to empower and connect the community to our people, programs, network, and technologies, be it in person, like a couple of months ago, which we all miss, or online like today. And now I'd like to hand the stage over to Anne from CodingGirls to share more about today's session. Over to you, Anne.
Yes, thank you, Joshing. Hi, everyone. I'm here from CodingGirls. So welcome everyone to today's sharing session. So recently, CodingGirls has started this program called Code With Cloud. It is an 8-week guided online learning program to learn about Google Cloud. So as part of the program, in today's session, we have Dan from Learn Kubernetes to talk about Kubernetes, and Andrea from Data Tonic to talk about how they help the client Lush implement a machine solution on Google Cloud. So at the end of each session, we will have a Q&A. So don't forget to leave your question on the YouTube chat. So without further ado, I will hand to our first speaker, Dan.
Hi everyone. My name is Dan. I am an instructor at Learn Kubernetes, and today I'm here to talk about Kubernetes. So what is it? Why should you use it, or should you not use it? Okay, but before we talk about Kubernetes, which you might have heard of, then let's take a step back, right? And let's see why this Kubernetes is needed. Why is so popular these days? Now, back in the days before Kubernetes was a thing, we used to have large applications, and these large applications were quite big. So in the recent past, what we found is that dividing them into smaller chunks actually makes a lot of sense, and we migrated towards this sort of microservice architecture, right? And we thought it's a good thing, right? It's good because we can deploy this application independently. Each team can work on a separate feature, and then if one breaks, then the failure is isolated, right? So overall, less risky. So we should do it, right? It's a really good idea. However, there are some downsides. So when you had a single application, what you used to do is you used to wrap that inside a virtual machine, inside a server, and then you deploy it, you're done. Okay, but now that we break everything down into smaller components, then what we need to do is, of course, we need to wrap each single component in its own virtual machine, right, into its own server. And since microservice is not just about 4 applications or more of them, then we face the challenge that we have got a lot of virtual machines, a lot of servers in our infrastructure. Okay, and when you have a lot of virtual machines in your infrastructure, then there are a couple of things that you might notice. So the first one is each virtual machine comes with an operating system. So it has an operating system, and then the rest of the resources on your virtual machine are usable for CPU and memory. Okay, so if you've got a few virtual machines with few large applications, then the ratio between what's usable by the operating system and what you can use with the application is quite small, right? So overall, running the operating system costs you about 2 to 3% of your resources. Those are resources that you have to rent from Google Cloud or Azure or AWS, and then you won't get back. But it's only 2-3%, so something that you can ignore. However, when you tend to use a lot of microservices or a lot of applications into smaller virtual machines, what happens is you tend to use smaller virtual machines. Okay, so 1 gigabyte, 2 gigabyte of RAM, maybe 1 or 2 CPUs. And what happens is the ratio between what is utilized by the operating system and what is actually available to you changes quite dramatically. So we're talking about 6 to 10%. So basically that means that every time you launch a virtual machine, 6 to 10% is used by the operating system, and that 10% cannot be claimed back. Okay, so you're wasting a little bit of resources by having smaller virtual machines and a lot of microservices. But that's not the only issue. The other issue that you might face is that usually we deploy applications using automated pipelines, right? So we might have a system that grabs your application, it packages it inside the virtual machines, and then deploys it. Now, when you provision this virtual machine before you deploy the application, you might actually decide to pick always the same size. You might be provisioning always a 16 gigabyte of RAM and 4 CPUs in virtual machines and just deploy your application, right? It doesn't matter if your application is small or large, you always provision the same virtual machine. Now, if you're dealing with few and large applications, that's not a problem at all. But when you're dealing with applications of all sizes, like in microservices, for example, you might have machine learning application that requires a lot of memory, or requires a lot of CPU, or you might have real-time application that use more memory. All of these applications come in different shape and sizes, which basically means that they will utilize your resources inside the virtual machines in different way, right? So in this particular case, you can notice that we're wasting quite a lot of space because we're always provisioning the same virtual machine. The third issue that we face is to do with dependency. So if you think about moving to microservices and just creating more applications, that what it tends to happen most of the time is that developers like to play with new languages, new frameworks, right? So not only we have more applications, but we also have a more diverse ecosystem, right? We have diverse programming languages, we've got diverse frameworks, and so on and so forth. So you might find yourself with all sort of languages in your company. And now, even if you decide, actually, I'm going to stick with Java for everything we do in our company, then even in that case, that's not enough, right? What happens is sometimes you have the same different version of the same framework or a different version of the runtime. You can see here Java 9, Java 10. So this is a little bit of a problem because it's very hard to standardize on a platform and provision virtual machines for such a platform. So what do? We have all of these problems. How do we fix them? So let's take a step back. So virtual machines are actually really good because they can isolate our applications, okay? However, virtual machines are not the only technology that allows us to isolate applications. So in a Linux kernel, for example, we've got two primitives, one called control groups and the other one called namespaces. Now, control groups is something that you can apply to a process and say, I want this process only to use 256 megabytes of memory, or I want this process only to use this bandwidth on the network card, right? And you can limit what it can do. So you can do things like CPU, memory, network, so on and so forth. And then again, inside the Linux kernel, we've got another primitive called namespaces. And namespaces are good because you can limit what a process can see. For example, you could pretend that the process has a full view of the network when in reality has not. You can just partition that and make sure they only see a subset. So what if you could combine these control groups for limiting resources and namespaces to actually limit what's visible from this process and make it available to your application, right? Perhaps you could package them in such a way that can only use a little bit of memory and can only see a slice of what the network interface can see. Now, if this sounds abstract, it's actually a little bit easier than you might think. So Docker is a very popular technology nowadays that actually popularized the idea of a container, what we called a Linux container. So a Linux container is basically just a way to limit, to restrict the view of what the process can do. And it looks a lot like a virtual machine, right? And the beauty of it is that we don't actually need virtual machines. When we run a server, we don't need virtual machines. We could potentially just remove all these virtual machines and then run all these applications as processes inside containers using namespaces and control groups. So what's the result? The result is that we can pack all of these applications very nicely together. Okay, so we've got more space for running more workloads. The other interesting thing is that because we're just launching processes, then it's just like you double click on Word on your computer, then immediately it pops up, right? So it's the same for container. It's basically just launching a process, and the process you can launch it in seconds. Whereas for virtual machines, it might not be the same. So virtual machines, of course, they emulate everything, even the hardware, and then they're fixed allocation, whereas with containers, we've got dynamic allocation. So that basically means that they use memory and CPU when they need it. You don't need to provision that up front. Okay, so this is actually a good idea, but there is also a third benefit of using containers, which is you usually package all of the dependencies together. So in the past, you might have asked someone else, could you please provision an environment for me so I can deploy my applications? Could you provision a Python environment so I can run my Django or my Flask app? With containers, we don't do that. What we do is we just describe what we want inside a container, and then we package everything, all of the dependencies together. And this is a really good idea because suddenly the infrastructure becomes agnostic. Okay, so if in the past we had to say, could you please deploy this Ruby on Rails application, and then we had to provision a Ruby on Rails environment, and maybe we had a variety of other apps. Now we don't need to do any of that. We just package everything as a container. They all look the same, and we just do run a container, 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 run a container. That's it. Containers are great, aren't they? Until they are not. When you start using containers, say, oh, this is really good. I can use it for everything I do, right? So, but the problem that we're facing is that we just basically, if we have a lot of virtual machines, that we'll have even more containers. And then the only things we've done is just removing this virtual machine and running this application as processes. So we haven't really solved the problem of how do we actually manage all of these processes. So if I had to do it myself, so let's say I've got a wish list of things I would like to do to manage all of these containers that we just talked about. I like to be very friendly, so it's something easy I can use, so I don't need to think about too much. The second thing that I would like to do is I don't really like to deal with a lot of servers. So ideally, I just want to say, hey, can you please deploy this? I don't really care how many servers you use in the backend. Okay, so ideally, I want to something that abstract my infrastructure, and instead of having like several servers, one next to each other, I've got just one big server. And then the last thing I really want from this software to help me deploy application is that I can actually write code and I can define my infrastructure as code. So if you use technologies such as Puppet, Chef, or Ansible in the past, then you might be familiar with the benefit of writing code as infrastructure. Now, it turns out that my wishes, they exist. So we have tools that are designed to run these containers, and they're called container orchestrators. So there are many containers orchestrators, but the reality is that Kubernetes is by far the most popular. So what is Kubernetes? Why everybody's using it? Why so much hype? Well, the reality is, like I said, Kubernetes is basically abstracting all of your servers. So you basically define, you have a service, you install Kubernetes on one, and then all of the rest of the servers are going to join the master node. And then what happens is Kubernetes will just count the memory and CPU for all of the servers that you give it to it, and then it would just basically treat it as a unique machine, right? You don't have to worry about it. The other interesting things about Kubernetes is that it's got a smart scheduler, which basically means that every time you submit a container, then Kubernetes will scan the infrastructure and will decide where to place this container. Okay, if another container comes in, and then we'll just inspect and move it on the other side. So it's basically, I don't know if you realize, but this Kubernetes is basically playing Tetris with your servers, right? It's trying to pack this infrastructure as efficiently as it can, right? So if you play the game long enough, this is what you will get to, which is great because you can do a lot more with a lot less. Right, so we can have more containers packed into the same server and can be very, very efficient. The other things that Kubernetes is, and this is perhaps the more interesting for me, that I come from a developer background, is actually the ability to change everything you do in Kubernetes through an API. And then you could basically, in this particular case, what I'm doing is just retrieving an API. If I want to retrieve what's available in a namespace, I can do an API. So in Kubernetes, we have an API for everything. So if I want to create a deployment, I use an API. If I want to create a load balancer, I create an API, and so on and so forth. And this is great because I could potentially write a lot of automation on top of this API. So in this particular case, I've got 2 nodes. So if I want to create a deployment, that's an API call. So if I want to create a new server, an API call. If I want to create a load balancer, that's again another API call. So very, very easy. So if you're familiar with a programming language, then you can just interact with the cluster directly and then just script everything that is there. So we talked about several things today. We talked about what are good about virtual machines. We talked about containers as a way to sort of as an alternative to virtual machines, as a lighter version of virtual machines, then we talked about several, a way to manage all of these containers that we've created today. We have created through microservices, and how Kubernetes has got 3 interesting properties to help you manage your workload. So we talked about abstracting your service as a single data center. We talked about an API, a powerful API that can be scripted, and we talked about a scheduler that allows you to play Tetris with your containers. So I would normally play a demo by now, but I think I'm running out of time, actually just in time as far as I'm concerned. So I just want to thank you everyone for listening to me. I hope you enjoyed.
Yeah, so we will have a Q&A session here. If everyone have any question, please leave your question on the comment from YouTube. Okay, so thank you, Dan, for the awesome sharing.
Thank you very much. Thank you.
Yeah, so now we will have our second speaker, Andrea from Datatolic, to talk about the machine learning solution they help their client Lush implement on Google Cloud. Yeah, over to you, Andrea.
Yeah, hi everyone. So unfortunately, I do think I have some background noise. I hope that's not too distracting. But if at any point I would not clear enough, you can hear me well enough, just point out a question in the comments and I'll answer. So yeah, my name is Andrea. I'm from I work at Datatonic, so I'm a data scientist. I thank you so much for the invite, first of all, to both Anne and the Coding Girls. I saw the program at for the bootcamp. It sounded really, really interesting. So I hope you are enjoying it so far. Today, what I brought was something slightly different from the previous talk. So not so much about a specific GCP service, but more on how can we tackle a specific business problem with GCP. So this specific problem is how can we help Lush go packaging free? So packaging free being label free, all the wrappings and packages around their products in store. And they want to do it with ML. So how can we do this with GCP? So first, a couple of words on Datatonic. So Datatonic is the company I work for. We are partners with GCP. So this means that we help other companies migrate or accelerate their solutions in GCP. So sometimes our clients come from Google that forwards them to us. Other times they come directly to us, as was the case with Lush. So we specialize in 3 main fields, so data analytics, data engineering, and data science. I'm in the data science department, so I'm mostly focused in AI and machine learning. So let's take a look at the agenda for today. So I'm aware that it is already quite a bit late over there, or wherever you are in the world, but in Singapore at least. Here in the UK, it's still not yet midday, so I'll try to have energy for all of us. So for the next 15 minutes, what we'll cover is first, what is this problem that Lush was struggling with? Then how did GCP solve it? And some final notes on the deliverables. Around halfway through it, I'll stop for a bit just to see if anyone else has some questions I can address. If not, you can ask them at the end. And if you just remember your questions later, you can also use my email address. So let's kickstart. Yeah, so Lush is a company mostly everywhere now. They're specialized in beauty products and handmade cosmetics. So they're very famous for their bath bombs, as you can see here in the picture, very colorful. They are also very environmentally conscious. So they came to us with this idea of being completely paper and plastic free in their stores. So as you can see here in the picture, so no labels, no wrappings or packagings around their products, and they wanted to do it with ML. So I actually checked just to make sure that you guys would know what I was talking about. So there are Lush stores in Singapore, and so some of you may have already been in a Lush store or know the store, or yes, so maybe this is an interesting use case for some of you or most of you. So Lush already had something in place. They had an image classification model outside of GCP. So it was only working for iOS and only working for 19 products. So our goal here was to improve what they had already. So we wanted to do something on GCP that would be compatible with both iOS and Android, and applicable for more than 19 products, because 19 bath bombs is not that much. Also, their image classification model was scoring a F1 score of 45. So out of 100%, there was still a lot of room to improve for sure. So on your right side, you probably noticed already, you get a glimpse of what this app is. So yeah, you just take your smartphone camera, you focus on the bath bomb, you wait a bit, it tells you the name of the bath bomb, and if you click on it, it will tell you more information like the ingredients and how to use it and so on. So yeah, this is the app. So how can we do it? So this is a very challenging project in terms of this specific characteristic, which is that it needs to be compatible with a mobile environment. So in reality, there are two ways that we can do this. So we can either have our image classification model in our smartphones, so in the app, in the Lush app itself. And in that case, we rely a lot on the processor that we have on our smartphone. So that will affect the way that our predictions are either slower or faster. It will also take some storage space and drain a bit of our battery. On the other side, we can have our image classification model in GCP. So in that case, we'll rely a lot on the internet connection and how good it is to make requests to the model, right? So here, the call was really on Lush, and they decided to go with the first approach. So that meant that as a requirement, we had to build a very small model in terms of storage. And this call actually was made because they were not too confident that they could have a good internet connection in all their stores, so a good call. But yeah, let's see how we face this challenge. So let's build a machine learning pipeline to fix this problem. So in this machine learning pipeline, we need to account for four main things. We have a lot of images of bath bombs that we need to process to make them usable by the image classification model. We need to make a model in an automated way. So for those of you that are not so familiar with it, this model will basically give a lot of examples of images of bath bombs together with their names. And the computer will learn the patterns that distinguish each bath bomb. And then to evaluate it, we give like a set of images that the computer has never seen before. And we ask him to classify like, what bath bomb are you looking at now? So that's how we know how good the model is doing. But we want to do this in an automated way. So we want to make sure that this happens every time we have new bath bombs coming in store. And we also want to monitor and track the performance of the model, and finally to store old and new models for future records. So this is how the pipeline looks like. So we'll have our images of bath bombs stored in Google Cloud Storage. So that's our data lake. It's incredibly good to store all kinds of files. In this case, it was images, but it suits many different types of files. And it's compatible with all the other services in GCP. So really good for what we wanted. After that, we'll go into a data preparation stage where we get our images prepared to be used for the machine learning, by the machine learning algorithm, which needs to be compatible with a mobile environment. So just a very quick break so far. I think there are no comments yet, but yeah, if you guys have any questions so far, anything that wasn't too clear, anything like, why are we doing this at all? Yeah, just. Otherwise, we'll deep dive on each of these steps now. So the data preparation first. So our images, they were stored in Google Cloud Storage, and they were fed into a data flow pipeline. So this pipeline was mostly converting images into TensorFlow records, so that the model could then use the images in this format. So these transformations were done both in the train and the evaluation sets, which were then stored in Google Cloud Storage. So this step here. And then as an extra step, we had data augmentation processing, which is done in AI platform, because for that, we need TensorFlow. So TensorFlow is a deep learning library that we wanted to use to do this data augmentation, and AI platform is compatible with TensorFlow. So that's why we did this step in AI platform. So data augmentation is actually a very cool technique, because it allows us to have many different images from one single image, and we do this by changing saturation, brightness, cropping, or flipping the images. So let's take a deeper look at how we converted these files. So these files were converted into TensorFlow records, as I said, and these are basically numerical representation of the images, which makes it easier for the model to use. We did it in Dataflow because it is our fully managed service in GCP that specializes in these sort of data transformations. So in this case, we did it in batch. And because TensorFlow is so powerful in this horizontal auto-scaling, we could convert around 50,000 images in 10 minutes, which was really great, really important for the pipeline. And we couldn't do it without this horizontal scaling, for sure. So again, to the pipeline, let's look now at the machine learning step. So we both trained and evaluated our models in AI platform. So AI platform is our development platform to build machine learning models. And most importantly, it is compatible with TensorFlow, so the library we wanted to use to build our model. So we built our model, we converted it into TensorFlow Lite on your right side, top right. So this format is a mobile-friendly format. We did it as well in AI platform. And then we stored the models in GCS. So at the same time, we stored the evaluation metrics, so for instance, F1 score, in BigQuery. And BigQuery here is our data warehouse, so no ops, completely serverless, very user-friendly, and that's why we used it to store our metrics. So you can now take a deeper look at the model itself. So as I said, we converted this model into a TensorFlow Lite format, which fulfills our requirement to have a small model, which is great. So it now takes 3.5 megabytes. We also applied some more advanced techniques on top of it, like quantization and transfer learning, which makes it easy to have a performant model in these conditions. And as a result, we have a model which works both in Android and iOS. We improved greatly the F1 score from 45 to 97, which is really good. And it now works for more than 500 bathrooms. So coming back to the pipeline, if you still remember, we wanted to do this as automated as possible. So to do this, we used Composer. Composer here is our framework for scheduling and to create flows of tasks. So for instance, here we have the image ingestion, then followed by the data preparation, then followed by the machine learning step. And each task here will only happen once the previous task has been successful. So here we can see the full pipeline. The way we automated it was on a scheduled basis. So weekly, the pipeline will check if there are new images of bath bombs. If indeed there are new images, it will run the next steps, so all the pipeline. If not, then it will stop there and won't run the rest of the pipeline. Yeah, and these are the deliverables in a nutshell. If you guys want to actually take a look by yourselves, the app is available at the App Store. And actually, Lush has two apps. So the one that has this functionality is the Lush Labs app. And yeah, if you go to this app under the Lush Lens banner, you'll find this functionality. You can give it a try inside the stores if you feel like it. So yeah, so far, any questions? I think there are some comments here on the comments page. So yeah, one of the questions was if the uploaded images are stored in GCP storage bucket. Yes, yeah, they are. So we have a bucket for these images, and then we have a bucket every time we saw the GCS being mentioned in the pipeline. We have a different bucket, so we don't mix our data. So after data flow works, yeah, and during AI platform works as well, we have all the data organized in different buckets. Not too sure. I got last question. So, so is the accuracy of the app to identify the product subject to end user's phone capability? So my understanding is that if it depends, if the accuracy depends on the phone, it does not. What will be dependent on the phone is just how fast it will give you the prediction, really. So it depends. Like if you have a more powerful phone, it will process things faster, a bit like it happens with any app, really. But the accuracy won't be depending on it because the model is the same for every phone. But yeah, let me know if this was not the question you had in mind.
I think the question may be related to like the image quality, where that matters to your model.
Oh, right. Yeah, the picture quality. Yes. So each image that you take will be a new input to the model. Also, more than the camera capacity, it also depends on the background. So if you're holding it, if you have a lot of noise in the background of the bath bomb, it will make it harder. So as a threshold, like if the model can't predict something with more than 99.9% of accuracy, it will give you the first three most likely bath bombs, if this makes sense. So it's actually something that we can see here. One of the examples shows that the model was not too confident in the first prediction. So it just gave two, and yeah, you see here. So it was not too confident on what it was looking at. So we will give you 1, 2, or 3 options that the user can then pick. And it probably be easier for the user to understand which one of the 3 it is. The processing.
Yeah.
Sorry, Anne. Okay. So I think, yeah, we had some slides on the processing here. I don't want to be lying to you. So yeah. So this was related to explaining the quantization and why it matters, because using this technique improves how fast the model will perform. So it depends also on the internet connection, but it is in the range of milliseconds.
There's another question. Is there a particular reason you store the trained model in Google Storage, on Google Cloud Storage?
Yeah, so we didn't actually serve the model. So that's why the model is not, say, saved in AI platform. We don't need to do it because we'll be using it then on the phone. So this will then be connected with the Lush app. And that's why we just needed to store it somewhere cheap with good regional coverage as GCS, so that it would be easier to then connect this to the Lush app. So once the model is there, it will be used on the app in frozen mode. So it's not that we are connected to a dynamic model all the time. So every time we need to change the model, we actually run and build another model and save it in GCS to connect to the app.
Any other questions? Please leave your question on the comments. Yeah, I think I will add them back to the screen because previously there's a question about when to choose Kubernetes and when it's okay to use containers. Dan, can you help to answer this question?
Yes, it is a little bit of a complicated question, I guess. So I think it's a little bit hard to tell when it's a good time and when it is not. So generally, if you're already using a platform that allows you to deploy, then the easy choice is to stick with it and to use what you're using already. Now, if you tend to have a lot of deployments, if you're sharing resources with a few teams or colleagues, and you want to standardize on the processes, you want to standardize on your deployments, then Kubernetes might be an option. Sort of a challenge with Kubernetes is that it tends to be quite complicated. So the first time you deploy something, it's rather complex, right? So you might need to learn a lot before you can start using it. So I think there is a trade-off between you learning it during the weekends or on the work and actually deploying production infrastructure on Kubernetes. So I think there isn't a clear cut, but yeah, you need to master the technology before you can deploy in production.
That's cool. Any other questions? Okay, great. So thank you so much, Dan and Andrea, for this awesome sharing. Yeah, thank you very much for your time and effort to make it happen. And for everyone on the channel, so please follow up on CodingGirls social media. We'll have more events coming up. And thank you, everyone, and good night.
Thank you. Bye.
Bye. Feel free to leave.